In this video, we're going to talk about continuous probability distributions. So here's an example of a type of continuous probability distribution. This one is called the normal distribution. Now it has the continuous random variable x. X could be anything. It could be 2, it could be 3.5, it could be 4.68, it could be anything along the x-axis. Now, if we had discrete random variables, x would have restrictions. It could be like 1, 2, 3, 4, 5. But when dealing with continuous random variables, x could be anything. It could take on any value. Now, on the y-axis, we have the function f of x, which is also known as the PDF, which stands for the probability density function. Now, f of x will tell us the height of the curve above the x-axis at some point x. So f of x will give us the distance between these 2 points. Now let's put some letters here. Let's call this A, B, C, and D. We're going to use that shortly, but one thing I do want to mention is that the total area under the curve for a continuous probability distribution is always equal to 1. So the area of the shaded region highlighted in blue, that's equal to 1. So I'm going to write TA for total area. That's 1. Let's say if we wish to calculate the probability that x is less than a, how would you do it? What you need to do is calculate the area under the curve of everything to the left of A. So it's going to be the area of the region shaded in red. Likewise, if we wish to calculate the probability that x is between B and C, what we need to do is we need to determine the area under the curve between B and C. Likewise, if we wish to calculate the probability that x is greater than D, we need to calculate the area under the curve to the right of D. So the probability is always equal to the area under the curve when dealing with a continuous probability distribution function. And keep in mind that f of x is always positive. It's greater than or equal to 0 for all x. So for a continuous probability distribution, you won't see the curve under the x-axis. It's always above the x-axis. Now, here's a question for you. What is the probability that x is equal to b? What would you say? Now, here we don't have a range of values. We simply have just a line at B. And for a line like that, the area is 0 because there's no width. You only have height but no width. If you try to calculate the area of a rectangle that only has height but no width, it's nothing. So whenever you try to calculate the area of a finite point, it's going to be 0. The only way you're going to get a value above 0 is you need to x has to have a range of values. It can't have a single value. So just keep that in mind. Now, another thing that you want to keep in mind, let's say if you wish to calculate the probability that x is less than a. This is the same as the probability that x is less than or equal to a, because the probability that x is equal to a is 0. So less than or less than and equal to, it's going to be the same. So let's say if we want to calculate the probability that x is between B and C, this is the same as the probability that x is equal to or greater than B, but less than or equal to C. So those are some other things that you want to keep in mind when dealing with continuous probability distribution functions. Now, we briefly talked about the shape of the normal distribution. There are some other continuous probability distributions you need to be familiar with. The next one is the uniform distribution. The uniform distribution has a constant f of x value, as you can see, and it ranges from A to B. Now, the area of the curve under the uniform distribution, or basically the area of the rectangle, is going to be 1. So let's say we have a uniform distribution from, let's say, 2 to 6. So A is 2, B is 6. If the area of the rectangle is 1, what is f of x? What is the value that corresponds to that point? Well, we know the base of the rectangle is 4. 4 times what number is 1? Because the area has to be 1. It's going to be 1 over 4. So that is going to be the value of f of x for this problem, for uniform distribution. Because if you multiply 1/4 by 4, you're going to get an area of 1. And so for any uniform distribution, the area under the curve has to be 1. So just keep that in mind. So now I want to give you some formulas that you need to know when dealing with the uniform distribution. So for uniform distribution from A to B, x will vary between A and B. The probability density function f of x is simply 1 over b minus a. In the last example, if you were to plug in a and b, where b is 6, a is 2, you would get the function f of x is 1 over 4. So that's how you would incorporate this formula to calculate the probability density function for a uniform distribution. Now the next thing you need to know is that the mean is equal to the average of a and b. So it's the sum of a and b divided by 2. And next is the standard deviation. That looks like theta, but it should be sigma. The standard deviation is the difference between b minus a divided by the square root of 12. So those are some formulas that you may want to write down when dealing with the uniform distribution, which is one of the types of continuous probability distributions that you need to know. Now, the next distribution that we're going to talk about is known as the exponential distribution. This is another continuous probability distribution that you want to add to your list. So it has a y-intercept, and then the function decreases over time, or with x. We have f of x on the y-axis, and the y-intercept is lambda, the rate parameter. The probability density function is f of x is equal to lambda e to the negative lambda times x. Lambda, the rate parameter, is 1 divided by the mean. So those are some things that you want to know for this type of function. And keep in mind the total area under the curve for this one or any type of continuous probability distribution function is always going to be 1. I had to erase a few things, but let's say if we have this point x and we wish to calculate the probability that x is less than x. So that is the area shaded in blue. The formula for that, to calculate the area under the curve of that region, it's going to be 1 minus e to the negative lambda times x. Now, if we want to calculate the probability that x is greater than x, it's simply e to the negative lambda times x. In this case, that would represent the region under the curve to the right. So those are some other formulas that you want to know if you need to calculate the probability or the area under the curve.